A few months ago I bought one of these. This is a Qidi X Smart 3 3D printer, a compact printer which is currently one of the cheaper printers on the market, being available at the time of recording for just £249 from the Qidi Tech website, with 5% off available on your first order if you sign up for their newsletter. Having used the printer for a few months, I'll be going over my experience using it and giving my thoughts on whether you should consider getting one. I'll start with a quick look at the X Smart 3 specifications. The X Smart 3 is part of Qidi's X3 series of printers, along with the X Max 3 and the X Plus 3. The X Smart 3 is the smallest of the trio, with an advertised build volume of 175 by 180 by 170 mm. The build volume is similar to that found on the Bambu Lab A1 Mini, though is smaller than some of the other competitors such as the Ender 3 or the Anker Make M5C. Other features include a 4.3 inch touchscreen, automatic bed levelling, built-in Wi-Fi, a single USB port, a double-sided magnetic build plate, and an enclosed chamber. The chamber is not heated, nor is it fully sealed, but it's enough to keep the print warm and keep out any drafts. This could also allow the use of some more temperature sensitive filaments, provided you're able to keep enough heat inside the enclosure. What makes the X Smart 3 particularly interesting is the Core XY design. In this setup, the nozzle moves along the X and the Y axis, while the build plate moves up and down on the Z axis. Not only can this make the overall printer size more compact, it can also potentially improve print performance because you don't have the entire weight of the bed being thrown around on the Y axis. This is something that you don't typically see on printers that sell for around this price point. To try and improve print quality further through reducing weight, the X gantry uses carbon rods rather than steel, which means less mass will be moving along the Y gantry, though we'll talk a bit more about that later on. That covers the basic specifications, so I'll now move on to the unboxing and the initial setup. The first thing you'll find when opening the box are some of the accessories that come with the printer, including a roll of sample filament, replacement nozzles, a bed levelling paper, and the filament spool holder. Removing this top polystyrene gives you access to the printer. To keep it secure in shipping, the top and side panels of the printer have been secured with tape, which you'll want to remove. In the polystyrene below the printer you'll find a glue stick. As is typical with 3D printers, there is also a USB drive included. We'll take a look at that a little bit later, but there is a quick start guide on there, which is also available from the Qidi website. While the X Smart 3 does come fully assembled, there are a couple of things you need to do before you can start printing. There are two bolts on either side of the bed which need to be removed, which are used to secure the bed and stop it moving during shipping. The print head is also protected with a cardboard cover that needs to be removed. One final thing to check is that the power supply is set to the correct voltage. This used to require the removal of the entire bottom plate of the printer. However, in the printer I have here, there is now a cutout section which allows you to see the switch on the power supply. This is a nice improvement to the printer, and it shows that Qidi are open to tweaking the printer designs based on the feedback they receive. I would say though that despite what the label says on this printer, it was correctly set to 230 volts, so don't rely on the label, make sure you double check it yourself. Once you're happy the power supply is set correctly, you can plug the printer in and turn it on to begin the initial setup. You can complete the initial setup without looking at any of the documentation. When it's first turned on, the printer will guide you through the process, and that includes removing any parts that need removing, getting the spool holder fitted, getting the bed levelled, and running input shaping. So I won't go through this in too much detail, but there are a couple of things that I do want to mention. As part of the initial setup, the printer will go through a process known as input shaping. This is quite common on printers nowadays, and the goal of input shaping is to allow the printer to compensate for any vibrations or resonance. This is particularly important during fast changes of direction, where such vibrations would have a bigger impact on the print quality. With input shaping enabled, you should notice less ringing and fewer bulges around the corners of your prints. Before running input shaping, you'll want to make sure that your printer is positioned where you intend to use it, and you should repeat the input shaping process should you ever move it. This is because the vibrations and resonance affecting the printer will differ slightly depending on the surface the printer is sat on. Input shaping will take a few minutes to complete, and it can be quite noisy as it steps up through different frequencies. We'll take a brief listen to the printer so you can get an idea of what to expect. The frequencies do go much higher, but I think you get the idea. Once this is done, if you don't move the printer, you shouldn't need to do this again, but the option is there in the settings menu should you need to rerun it. When setting the Z offset, you'll need to be mindful of the direction of the controls that you need to use. As someone that's only ever used a bed slinger in the past, I'm used to having to lower the nozzle towards the bed if prints aren't sticking correctly, or raising the nozzle if it ends up too close to the bed. This is the exact opposite of how it works in a Core XY printer, because in this case you're actually controlling the height of the bed and not the height of the nozzle. Therefore, to move the two closer together, you need to move the bed upwards, and if they're too close, you need to lower the bed away from the nozzle. It's just something to be aware of, particularly if you're used to using bed slingers like I am. Once the initial setup's complete, you're now ready to start printing. And that's where we'll be taking a look at the USB drive that was included with the printer. On the USB drive, you'll find a copy of the user guide, plus some pre-sliced files that you can use to test the printer. The 16GB of space should be plenty, though you don't necessarily need to use the USB drive, because you can send files to the printer over the network, and we'll take a look at that a little bit later on. Also included is a copy of Qidi's slicing software. This slicer is Qidi's fork of Prusa slicer, and while it's perfectly acceptable to use, I'd recommend taking a look at some alternatives. The slicer I tend to use is Orca, which is a fork of Bamboo Lab slicer, which is itself a fork of Prusa slicer. There's a lot of forks going on in the world of 3D slicing software. Qidi Tech do actually sponsor Orca slicer, and the profiles are all there and available, so that's the one I'd recommend you to take a look at. I think I've talked enough now about the printer and the setup process, so let's take a look at some of the prints. The first thing I decided to print was, of course, a Benchy. I did use Qidi's pre-slice model for this, which has presumably been sliced with settings to try and give the best possible result. The print only took around 18 minutes to complete, and I have to say I'm really happy with the quality of what it produced. Next, I decided to have a go with a couple of files that I'd sliced myself. I did this using the pre-configured 0.2mm profiles in Orca. The first model I sliced was this micro SD card holder, which is a print-in-place model, and so it requires decent dimensional accuracy. The hinge came out nice and smooth, micro SD cards fit tightly in place and they don't fall out. And overall, I'm really pleased with the quality of this print. You can also see the effect of the textured surface of the printed bed, which on this particular print gives a nice finish to the outside of the micro SD holder. Though you can purchase a smooth build plate if you'd rather have a smoother finish for that bottom layer. The next model I printed was an LED cover, which is my own design. Again, I'm really pleased with the quality of this print, particularly the top surface. As for this print, I turned on the ironing option in the slicer. This does an extra pass over the top layer with a very low extrusion rate, which does a great job of smoothing out any imperfections in that layer. The only issue with this print was a little bit of stringing around one of the corners, which was quite easy to remove and not really much of an issue. I originally printed this a few years back on an Ender 3, and if I put the models side by side, you can see a massive difference and a huge increase in quality with the X Smart 3 compared to the old model. Admittedly, I did tweak the model slightly to make it thicker, so it's not an exact comparison. But it's a good comparison of what the X Smart 3 can do out of the box compared to an Ender 3, which had been upgraded and had a lot of tweaks done to it to try and get it to print better, something I never really managed to achieve. We'll have a quick look at two other prints that I've completed with this printer, starting with this housing for a laptop optical drive. This again has a nice finish, and the layer lines in this print are barely visible, bearing in mind that this was printed in the vertical orientation. It's a tight fit around the drive as it's supposed to be, but I had no problem slotting it into the enclosure. One thing to note with this one is that there is some ringing visible on two of the corners, something I can hopefully reduce by tightening the belts. The last print we'll take a look at, which is probably my favourite print so far from this printer, is this CR2032 battery holder. Not the most exciting thing to have as your favourite print, but I think the surface finish on this one looks really good. Aside from the visible seam, which really is down to the slicing more than the printer itself, the print really is immaculate. The lid moves nice and smoothly, as does the little tray that sits inside the housing to actually hold the batteries. All of the prints we've looked at were printed using the same filament, which is Qidi X PLA Rapido. This is the same filament that's included as a sample, but I chose to get a couple of rolls to go with the printer when I purchased it. It's the only filament I've printed with so far, but I don't see why it wouldn't give similar results with other filaments. So we've seen the results that the printer is capable of, but I want to talk a bit now about the actual experience of printing with this printer, and I'll start by looking at the user interface. The X Smart 3 has a 4.3 inch touchscreen with a resolution of 480 by 272. It's not an amazing screen, but the quality is more than enough given its small size. I'd say the size overall is adequate, though some of your file names will get cut off if they're too long, which can make it a bit more tricky to find the file that you're looking for. All of the expected functionality is included, with the ability to home and move the bed, set the Z-axis height, redo input shaping, configure the network, and load and unload filament. I do have a slight issue though with the way that loading and unloading filament is handled, particularly since a recent UI update. Unlike in the previous firmware, there are no buttons to manually control the extrusion, which is what I used to use when unloading filament. Instead, the UI now has options to load or replace filament, which are presumably there to try and make this process easier. While they do make sure the hot end is up to temperature, which is previously something you had to do yourself, as far as I can tell, both options seem to do exactly the same thing. They get up to temperature, and then they cause a length of filament to be extruded. Now, I'm not sure if I'm missing something here, but I'm not entirely sure why unloading filament would cause the filament to extrude. I'd instead expect the filament to retract out of the hot end so that you're then able to remove and replace it. Now when I replace my filament, I have to resort to using the web interface, which does still give you the controls to manually retract the filament. Starting a print is as simple as going to the file manager and finding your file. If files are uploaded using the web UI, they can be stored directly onto the printer's built-in memory, though be aware that the space here is limited. If you use a USB drive, your files will show up in a subfolder, which will appear at the top of the file menu. You'll also see an entry which allows quick access to the last thing that you printed, which is really convenient if you want to reprint the same file a second time. On selecting a file, the printer will show you some basic information about the print, such as the amount of filament expected to be used and the time the print is expected to take. There's also an image preview of the print, which is really useful in making sure that you've got the correct file. Now, previous versions of the firmware only seem to show these images for prints sliced with Qidi's slicer, though a recent update seems to have fixed this now, so that prints sliced in other slicers will also display a preview. Certainly, all of the recent prints that I've tried, which were sliced using Orca Slicer, now have this preview displayed, though it can take a little bit of time for it to be generated. Also on this screen is a checkbox to decide whether you want to level the bed before printing. I always leave this ticked, as it doesn't take long to do, and should help to make sure that the first layer sticks nicely onto the bed. Once you've started the printing process, it'll take a few minutes for the nozzle and the bed to heat up before the printer will actually start to print. The imprint user interface gives you some limited control over the way the print is progressing. If necessary, you can adjust the Z offset to make sure you're getting a good first layer. There are also options to control the flow rate, the speed of the fans, and the print speed. While the UI does show you the expected time remaining on the print, I find this to be very unreliable, and I find the time stated by the slicer seems to be a much better estimate. If your printer's connected to the network, you'll also be able to access the web interface. To do this, you'll need to take the IP address shown on the printer and add the port number 10088, so the resulting address will look something like what's on the screen now. The interface used by the printer is called Fluid, and this is something that is used on many other printers using similar software. It comes with a full suite of controls to change pretty much anything on the printer, including the extruder and bed temperatures, retracting and extruding filament, altering speeds and flow rates, and controlling fans. It has a console so you can send commands to the printer directly, a file listing so you can see all of the files that you've printed, a bed mesh to visualise how flat the print surface is, configuration for Fluid itself, which I don't recommend messing with, and some general information about the hardware. If you purchase the camera accessory to go with the printer, you'll also be able to watch your prints in real time through this interface. If you're using something like Orca Slicer, it includes a tab that allows you to see this interface directly in the slicing software. When connected, it's also possible to upload the file directly from the printer and start the printing process once it's sent. So far, we've talked about a lot of positives about this printer, but that doesn't mean it doesn't also have its downsides. Something you'll notice as soon as you turn the printer on is just how noisy this printer can be. And this isn't so much the noise when it's printing of the actual motors and belts moving. The noise is actually coming from the cooling fan used for the motherboard. Here's a clip of the noise that the printer makes when it's first turned on. And here's what it sounds like during a print. I plan to look into replacing this fan at some point, hopefully for something a little bit quieter. It's also possible to alter the way this fan is connected to the board so that it only turns on during a print. I initially had issues getting the printer connected to my home network. Although the printer could see the network and the password entered was correct, the printer refused to connect. This meant for the first few weeks of owning the printer, I was having to print files using a USB drive. But another feature that Qidi have added in a recent firmware update is the ability to log in via SSH, and this gives you access to the underlying firmware that's running on the motherboard. The X Smart 3 isn't advertised as having Ethernet, but there is an Ethernet port available on the board. And so the way I got my Wi-Fi working was to connect the printer to the network using an Ethernet cable. To access this port, I didn't remove the board entirely, but I loosened it just enough to get an Ethernet cable plugged in. With a wired network connection established, I was then able to log into the system and manually connect it to my Wi-Fi network. Since doing that, I have no problem with it connecting to the Wi-Fi, so I have no idea why it wouldn't connect using the printer's UI. So far, I've only used the printer with the stock 0.4mm nozzle that the printer comes with. If you're looking to replace the nozzle, it's worth bearing in mind that the stock nozzles used by Qidi are slightly shorter than the standard size that you find in a lot of printers, and this means a lot of third-party upgraded nozzles will have a small gap at the end of the thread due to the extra length. It also means the nozzle will sit slightly lower than the original, though this shouldn't be a problem. Unlike the other printers in Qidi's lineup, the X Smart 3 uses carbon rods for the nozzle gantry, and these need to be wiped on a regular basis to keep them clean. That's because the carbon rods are not replaceable, which means if the rods get damaged, you'd have to look at replacing the entire gantry, and that's assuming you'd even be able to get hold of one, as at the time of recording, Qidi don't sell these parts separately. Due to the uniqueness of this design choice, it remains to be seen how long these carbon rods will last. The larger X+3 model also used these carbon rods, though in a later design revision, Qidi swapped these for the more conventional steel. If I had a choice, I'd have liked to see the X Smart 3 also switch to more conventional rods. That said, they're not causing any problems so far, and hopefully that will remain the case in the longer term. So that was the Qidi X Smart 3 3D printer. And the important question to end this video is, would I recommend you buy one? And based on my experience using this printer for the last few months, I can say that I would definitely recommend it. While it does have a limited build volume, you'll struggle to find another Core XY design printer for a similar price. The print quality has been fantastic, and a few niggles aside, there haven't really been any issues for me to talk about. If you're in the market for a low-cost 3D printer, you should definitely be considering the Qidi X Smart 3. I hope you liked this video. Thank you very much for watching, and be sure to stick around for the next one.